You know, standing water on Mars.
Yeah.
Let's look at an image of that. Let's look at number 13. This is from space. Okay.
Yeah, this particular image is it's kind of a, if you think about the central image is the broader central image is a crater with a shadow in the crater, and the bright part of the middle is like the bottom of the crater, which is in sunlight. And if we just show the next image, which is zoomed into the centre of that crater.
Okay, let's look at the next image. Let's look at number 14. This is going to be, this is a stunning image. Here we have what might very well probably be a sea or a lake, I suppose, with something floating in it.
Yeah. The justification for the argument of it being water on a lake is that if you look at if you go to the websites at NASA and find the particular image, you can find these on my website. I'll put the actual names of the photographs so you can actually find them. The actual the terrain on the left-hand side, you can actually see detail. You can see rocks and boulders, small, detail.
It's quite, because it is quite high resolution. Yeah. We looked at this before the show, and it is.
But in the gaps between the black spots on the right and the part on the right-hand side, it looks completely opaque. So there's a difference between the terrain on the left.
Is this a monochrome image, by the way?
As far as I know, they might be using multiple channels they might be using multiple colour channels to render it, but it's just obviously grayscale image.
Yeah, okay.
It's not true colour.
So, all right, sorry, I interrupted you there, but between the black blobs, you can see what looks like an opaque sort of...
Yeah, the texture is there's no texture, it's all opaque and smooth. But at the same time, on the left-hand side, the outside of the kind of blobs, you actually see detail. You can see what looks like boulders and rocks to a degree. So
if this was a picture taken of the Earth from space, you would have no hesitation in saying, well, it's a lake with a lot of weed floating in it, wouldn't you?
Material floating in it, yeah. It could be like oil floating in it for something like that,
But if it was oil, it might clump a bit differently, mightn't it?
Well, yeah, I guess so. Could be a nice bulb. But yeah, one of the interesting features on this, if you look to the top left-ish, or just nearly to the top left of the kind of the blobs, you'll see where it's kind of smeared over the kind of sand, which kind of looks like
a wave.
It looks like it's a lake, and it's actually receded down the hillside there, which has left a streaking. Whatever these blobs are, it's left them streaking on the side. Like you say, if this was on Earth, we'd assume that it's probably like something growing in the water.
Well, evaporation would take place faster, wouldn't it, on Mars, because it's less gravity.
Yeah, but look, we just had the cold winter, and look what we do. We throw salt into the water to make sure that it doesn't freeze. It stays liquid at low temperatures. Mm-hmm. So one of the explanations NASA have had for years for having liquid water below zero is because it's full of salts, and it's chemically different to it's not pure water. It's got things in there which allow it to be liquid below freezing below 0 degrees C. But it also means that you won't necessarily, when you get saturated solutions, you're not necessarily going to get the same amount of evaporation.
So what's the climate like on Mars in terms of the temperatures? Because it's obviously a colder planet than Earth.
Yeah, it's further from the sun. It gets its poles. Obviously, it's got two ice caps, and the ice caps are basically made of water ice and carbon dioxide ice. The planet's kind of unique in our solar system in that the major component of the atmosphere, which is carbon dioxide, when the planet cools down in the winter months, actually precipitates out of the air. So the actual carbon dioxide snows. Yeah, the equivalent would be like Earth on the Earth if it snowed nitrogen. But what that would mean is that the atmospheric pressure would decrease. And obviously, if you're going through the seasons on a planet, you have one side is like summer, one side the north will be summer, the southern will be winter. Well,
it's tilted at an angle like the Earth, then, is it?
I don't know. Mars isn't. On the Earth, we have seasons because the Earth's tilted.
Yes.
But on Mars, I think maybe there is a tilt because it has seasons. But one of the major factors that indicate the temperature is its distance from the sun. It's got much more. It's got much more esoteric kind of. Can't we think of the word? But its orbit is very much more off centre.
It's more erratic, isn't it?
Yeah. It goes much further from the sun, and I think it's about 20% difference the distance between the sun.
So when it's near the sun, it's considerably warmer, presumably.
Yeah. But that's not obviously seen on things. So let's see in one complete sweep. It might just be So it's basically the distance from the sun that's controlling the temperature on the planet. Now, I don't actually know what distance it was from the sun in the 70s and what distance it is from the sun now. It's been speculated by some people. I've heard people talk about the reason what it's currently warm, but Mars is currently warming up. Mars is currently undergoing global warming. The current ice cap.
I've got to say, it must be all those Martians burning fossil fuels.
It's all these fossil fuels. But actually, one of the things is it's not just the Earth and Mars that warm. There's quite a few other planets. But as far as from we're talking in the context of this conversation, for life to evolve, if we've had Mars as a very cold, frigid planet for a while, if it suddenly warms up for whatever reason it happens to be, whether it's the sun outputting more heat, maybe if the sun is controlling the climate on this planet and other planets and that planet, maybe there's a situation sometimes happens where Mars is actually a bit more habitable than we actually currently know it to be.
Well, okay. Well, maybe you don't know this, and apologise for asking you if you don't know. But what are the average sort of daytime temperatures? I don't know. Let's say on the equator.
The equator gets above zero. Richard Hoagland once mentioned. I know it's definitely above zero in the summer in the daytime. I've heard he did a presentation. Richard Hoagland did a presentation where he said that the temperature would actually basically. He claims that NASA are lying about the temperatures they're publishing, for one. So he says that we can't, for various reasons, which we don't have time to go into, and I don't, full enough, don't know the details of. He claims that the temperatures and pressures that we're being told by NASA about Mars are just basically false. But I don't have the detail. I don't know what to say. But what we do know is that the temperature at the equator is above zero in the summer. Hoagland claims it gets to 20 degrees centigrade. Okay. But as far as the poles are concerned, it's obviously it's below freezing. But yeah, it goes minus. The coldest place on Earth is Vostok in Russia, and it gets about minus 88 or 78 or something. Well, Mars is down into minus hundreds. It's very, very cold.
But I was just thinking about the water thing. Because there's less pressure, because the gravity is less, and water boils at a lower temperature up a mountain on Earth, doesn't it?
Yeah,
it's not 100 degrees because the pressure is less. If the pressure is considerably less on, because the atmosphere is much thinner and gravity is less on Mars, then you could have liquid water at a temperature which is actually colder than.
You've actually hit something. That's a contradiction, because it does contradict. NASA have now acknowledged that they found water on Mars. Prior to the Phoenix lander, which landed in 2007 in the North Pole, prior to that, they've announced the discovery of water on Mars 4 times. But each one of those was using remote sensing. When the Phoenix lander landed on Mars and did its experiments, it actually detected, using wet chemistry techniques to detect water on Mars. Basically, it tasted water. So it's the first time they found water on Mars. But basically, so they're finding water, and it's in an ice form. But you mentioned obviously because the air pressure is different, so we're not necessarily going to get liquid water. Well, if NASA are maintaining that the streaks that they're seeing is actually possibly liquid water, well, that contradicts the reasoning for them having an atmospheric pressure of less than 1% of Earth's, because, like you say, the air water would boil if it was a liquid. Yeah.
Okay.
I just think, Joe, you made me think about that just then. That was interesting.
Okay, so we've seen something that is floating in what looks like water. It looks like something floating in water that could be organic. And Denise in Cambridge says, don't say oil, there will be a stampede to get there first.
Maybe that's where Bush wanted to go.
Well, it occurs to me that if it were oil, and if it's like oil on Earth, that is supposed to have been formed from a marine animal life that fell to the bottom of an ocean. Yeah, there's actually and got crushed. So even if it was oil, there's an argument that it's organic. The
same line though. You have one of the moons of Saturn called Titan is actually made of hydrocarbons. Yeah. So there is a physical, another non-biological process to make hydrocarbons, which is what oil is. And there's also the abiotic theory of oil, which basically suggests that all the oil on planet Earth isn't caused by dead dinosaurs and plants, but is actually natural.
It's caused by bacteria.
Yeah.
Well, I've read, and I obviously don't know how true this is, but I've read that there are oil people who say and swear that empty oil wells are filling up again.
Yeah.
But I don't suppose it's anything that we're going to hear from any of the big petrochemical companies, because it might change the geopolitics a bit if it's true. But anyway, let's moving on. So, okay, we've seen, what I was trying to say was we've seen stuff that might be life floating in what might be ponds on Mars. Could there be bigger organic structures on Mars? Let's go to number 15.
Yeah, this picture was taken from the Mars Global Surveyor orbiter in August 1999, so 10 years ago.
And what does it show us?
Well, it shows what can really describe as dendritic patterns from dendritic, which means branch-like, tree-like patterns. Fundamentally, the circular images at the top and look like trees. They look like the tree-shaped objects. Now, this can be two things. It can be geological. This could be caused geologically or possibly biologically through biological processes. These could be trees.
Well, let's look at a close-up. Let's look at the next image, number 16.
This is like a close-up. So we see lots of small images. We see this